Hello everyone, my name is Chen Huang. I come from Taiwan Chaoyang University of Technology. My talk is the influence of the angle of feature point for indoor positioning by machine vision. This is my outline. Introduction. In the previous work, 3D scanner used to obtain known environmental features and image processing technology is applied to achieve positioning function, but did not further analyze the accuracy of this method. In this paper, we will experiment with the proposed indoor positioning technology to understand the influence of its positioning. Indoor positioning method. Our camera is placed indoor and overlooked from top to bottom. There are 4 feature points: F1, F2, F3, and F4. On the 4 walls, every 2 of these 4 feature points came from a circle we see. The angle between the sum of these 2 angles is the angle between the F1 direction and the F2 direction. When the location of F1 and F2 with the angle are known, the location of the camera can be R1, R2, R3, or any point on the circumference. A circular expression can be obtained by every 2 feature points captured by the camera. The possible position of the camera is on this circumference. We can get an intersection every 2 circles. In our example, we can get 4 intersections as denoted with C1, C2, C3, and C4 in Fig 2. The average of these 4 positions is the camera position, which is the positioning result. Simulation space experiment and result. We made specs of 90 cm times 60 cm times 30 cm. The simulation space. 4 colors on the 4 sides of this space are used as feature points. The camera we used is Reseta S, which is a camera that can take panoramic views. We placed the camera in 2 locations in the simulation space are point 1 and B. Each position of the camera shot images in 2 directions, and the image of 4 directions A1, A2, B1, and B2 can be obtained. We can easily find out 4 feature points for the 4 images by color features. The angles emitted by the 4 images to each feature point are shown in Table 1. We can see that when there is an angle is large, the error will be increased. Real space experiment and result. This space is room M218 of Chaoyang University of Technology, with a space of 7.1 meter times 6.8 meter. The location of the 4 colors papers are known. We randomly take 2 locations of the camera in this space as shown in point 1 and point B. We shot 9 images each position. We will address the camera's shooting angles in each time we shoot an image. Each image is calculated by the proposed method to obtain the angle of each feature and the positioning error. From Fig 6, we can see that there are two errors greater than 20 cm, where each feature point has an angle greater than 72 degrees, and another feature point angles greater than 52 degrees. In 3, one angle is greater than 72 degrees, but the other three angles are less than 40 degrees. In 8, there are two angles greater than 75 degrees, but the other two angles are less than 30 degrees. For Fig 7, only the error of 4 is greater than 20 cm, where there are two feature points have angle greater than 73 degrees, and even one of them over 80 degrees. Conclusion: according to the experimental result of the simulation space and the real space, we know that the angle between the feature direction and the camera shooting direction will affect the accuracy of the positioning. The image taken by the fisheye camera will be distorted and reduce the resolution, especially when the object is at the edge of the image. In the case that there are enough feature points, the feature points with large angles can be discarded to improve the accuracy. At the same time, if we can understand the distortion feature of the fisheye lens, we can also improve the positioning accuracy. Thank you for your listening.